Right? Molar mass tells us the mass of 1 mole of my substance. We talked a little bit briefly about what a mole is, right? A mole is similar to a dozen in that it's the same number of things no matter what you're talking about, right? A dozen always means how many? 12, right? A baker's dozen always means 13, right? You know those numbers based on the nickname we gave them, right? Dozen always means 12. Mole is the same thing. The number's just a lot bigger. Okay, 1 mole of anything is 6.022 times 10 to the 23rd of that thing. Do you remember talking about this very briefly? Okay. A mole is 6.022 times 10 to the 23rd of anything. Right? If we have that many atoms of hydrogen, that means we have a mole of hydrogen. Okay? If we have this many water molecules, that means we have a mole of water. Right? Does that part make sense? It's just like a dozen, except it's a much bigger number that goes with it. Okay, so when we ask about molar mass, we want to know how many grams does this many molecules of water weigh? Or how many grams does this many hydrogen atoms weigh? Okay, so you can find the molar mass of elements by themselves or of compounds, right? And elements, finding the molar mass of elements is really simple. Finding the molar mass of compounds is just the addition of those elements. And so we're going to look at what that means. Okay. The molar mass of any element is given to us on the periodic table. It's given to us. Molar mass of any element is given to us on the periodic table. And numerically, it's the same value as our atomic mass. The only difference is that for atomic mass, we're looking at an individual atom. And for a molar mass, we're looking at the mass of a whole mole of those atoms. Okay, so go ahead and get this written down, and then I'll talk through that a little bit more. So finding the molar mass of elements is really easy. It's the same as the atomic mass, right? It's the same number as the atomic mass. It's just different units. Okay, so I asked for molar mass of oxygen. What would you tell me? If I asked for molar mass of oxygen, what would you tell me? 16 grams per mole, right? Are we understanding the units here? Grams per mole. All it's saying is that it's 12 grams per 1 mole of carbon, right? 1 mole of carbon weighs 12 grams. That's it. Grams per mole. Okay? If I wanted to find the molar mass of a compound, all we do is take into account the molar mass of each element in that compound. Okay, we take into account the molar mass of all atoms in the compound. So if you don't have your periodic table out, now would be a good time to grab that, because we're going to start doing some math with that. If I want the molar mass of this compound, which is, what's this compound? Water, right? If I want to find the molar mass of that compound, I take the molar mass of hydrogen. How many hydrogen atoms do I have? 2, right? I have 2 hydrogen atoms. 2 atoms times the molar mass, which is 1. That gives me a total of 2. How many oxygen atoms do I have? 1. Right, here's hydrogen. Here's oxygen. Molar mass of oxygen is 16. So I add those up and I get a total of 18 grams per mole. That's molar mass of water. If I took exactly 6.02 times 10 to the 23rd molecules of water and I put them on a scale it would weigh 18 grams. Okay. For our molar masses from the periodic table, most molar masses can be rounded to the whole number, especially within our first 20, right? When we memorized those, it was for things like this, so that you were faster about recalling those numbers, right? Once you become familiar with the first 20, it will make problems like this so much easier, right? I know hydrogen's 1, I know oxygen is 16, so I can do my math faster. Okay, so a lot of our numbers can be rounded to whole numbers. Exceptions within the first 20, magnesium is 24.3, we don't round that one. Chlorine, we don't round 35.5. There'll be some other ones, but those are common. Okay. Questions about how I came up with that? 2 hydrogen atoms, they each weigh 1. 1 oxygen atom weighs 16, so I got a total of 18 grams per mole. Okay. All right, I don't want you to write down the process. I want you to look at a problem. Okay, so let's say that I had, let's say I had Al2SO4 3. Let's say I had this compound. A little bit more intense, right? Let's break down how many of each atom there are to begin with. Okay, so let's talk big picture right now. Okay, I'll kind of draw it out here simply. I have 2 aluminum atoms. How many of these SO4 molecules do I have? I have 3 of these whole molecules, right? SO4 is a compound, and I need 3 of those. So it would look something like this. SO4, 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 right? I have 3 of those things. Does that make sense? This is not chemically correct, but this is the picture, right, that you need. Right? I've got 2 aluminums and 3 of those SO4 molecules, right? So how many sulfur atoms in total do I have? 1, 2, 3, right? This 3 gets distributed. How many oxygen atoms do I have? 4 times 4. I'm sorry, 4 plus 4 plus 4. So I have 12. So you don't just add these together and say I've got 7 oxygens, because that's not true, right? I have 4 oxygens per molecule, and I've got 3 molecules. So the parentheses, the numbers outside the parentheses, distribute through that. They get multiplied through that. Okay, is that making sense? Yeah. What happens if there's not a subscript right there? What do we know there's there? If there is not a subscript written, right, we assume it's a 1 right there. Okay, but if there's a 1, it just doesn't get written. Okay, so if there's nothing there, we assume a 1. So, I said for aluminum, I have 2 aluminum atoms. Each of them have a molar mass of 27, right? 26.98. That's really close. I'm going to round it up to 27. Okay? If you are not seeing where I'm getting these numbers from on your periodic table, you need to ask so I can show you. Okay? Sulfur, we said, has 3, and sulfur's mass, okay, I want everybody seeing that. Oxygen, we said there are 12, and we know it's 16.
So the 3 only gets distributed between the sulfur and oxygen.
Right. The 3 does not carry all the way here. It only carries through the parentheses. Right? It carries just through the parentheses.
So it carries 4 and oxygen and sulfur.
Right. It goes to every element that's inside those parentheses. Okay?
Are there actual compounds that are made of other compounds?
Right. That's a legitimate compound. That's called aluminum sulfate.
Right.
All right, so let's see what our total is here.
So you add up all the last numbers?
Okay, first one right here. Oops. It's important for us to think about that 3. Does this 3 go to all of these things? No, there's no parentheses. So the subscript is only attached to the element it's attached to, right? Without parentheses, they're just with that element.
Do you want us to round to 108 or 100?
For which one, silver? I would go 107.87 or 107.9, right? If it's not to a whole number, I would try to keep it to at least one decimal, if not two. Okay. So how many silver atoms do I have? I have 1, so I'm going to go 107.9 plus nitrogen, which is 14, plus 3 oxygens. Right? You can figure out whatever way works best for you to show your work. But when I've just got one of each, it's easy for me to just add them up and say, okay, I got 16 per oxygen, but I have 3 of them this time. So I'm going to add that up. Yeah, Joseph, I'm sorry. Did you have a question?
No.
That's okay. Seeing where it's... Is that about what we had? 169.9? Or no?
Wait, silver?
Molar mass, which is really what we're going to be using from here on out. We need to use grams per mole. If I ask for atomic mass, we use AMU. Right? In our real world application, it will much more often be grams per mole, but you will still see questions about atomic mass in which you need to give the atomic mass unit. All right, so make yourself a little note. Molar mass equals grams per mole. Atomic mass equals AMU. I'll tell you up front, you will have to label those correctly on the test, right? I would give you, tell me the atomic mass and tell me the molar mass, and your units will have to be correct. Okay.